PGTRP Mathematics Syllabus Unit 1 Algebra Groups Examples Cyclic groups, permutation groups, Lagrange's theorem, cosets, normal groups, homomorphism theorems, Cayley's theorem, Cauchy's theorem, Sylow's theorem, finitely generated abelian groups, rings, Euclidean rings, polynomial rings, UFD, quotient, field of integral domains, ideals, maximal ideals, vector spaces, linear independence and bases, dual spaces, inner product spaces, linear transformation, rank, characteristic roots of matrix, Cayley-Hamiltonian theorem, canonical form under equivalence, fields, characteristic of a field, algebraic extension, root of polynomials, splitting field, simple extension, elements of Cayley's theory, finite field. Unit 2 Real analysis. Cardinal numbers, countable and uncountable cardinals, Cantor's diagonal process, properties of real numbers, orders, completeness of RLUB, property in R-Cauchy sequence, maximum and minimum limits of sequence, topology of R-Hahn-Borel, Bolzano-Weierstrass compact if and only if, closed and bounded connected subset of R, Lindelof Coverings theorem, continuous function in relation to compact subsets and connected subsets, uniformly continuous function, derivatives, left and right derivatives, mean value theorem, Rolle's theorem, Taylor's theorem, L'Hospital rule, Riemann integral, fundamental theorem of calculus, Lebesgue measure and Lebesgue integral on LH sec integral of bounded measurable function, other sets of finite measure, comparison of Riemann and Lebesgue integral, monotone convergence theorem, repeated integrals. Unit 3 Fourier series and Fourier integrals. Integration of Fourier series, Fedger's theorem on C.1, summability at a point, Fedger's Lebesgue theorem on C.1's summability almost everywhere, Rice-Fisher theorem, Bessel's inequality and Parseval's theorem, properties of Fourier coefficient, Fourier transform in L minus d, Fourier integral theorem, convolution theorem for Fourier transform and Poisson summation formula. Unit 4 Differential geometry, curves in spaces, Serret-Frenet formulas, locus of centers of curvature, spherical curvature, Intrinsic equation, helices, spherical integrated surfaces, envelope, edge of regression, developable surfaces associated to a curve, first and second fundamentals form, lines of curvature, Vigneault's theorem, Poisson curvature, Euler's theorem, Dublino's indicatrix, surface of revolution conjugate systems, asymptotic lines, isometric lines, geodesic. Unit 5 Operation Research, Linear Programming, Simplex Computational Procedure, Geometric Interpretation of the Simplex Procedure, the Received Simplex Method, Duality Problems, Degeneracy Procedure, Perturbation Techniques, Integer Programming, Transportation Problem, Nonlinear Programming, the Convex Programming Problem, Dynamic Programming, Approximation in Function Space, Successive Approximation, Game Theory, the Maximum and Minimum Principle, Fundamental Theory of Games, Queuing Theory, Single Server and Multi-Server Models, MGI, GMI, G1I models, Erlang Service, distribution, cost model and optimization, mathematical theory of inventory control, feedback control in inventory management, optional inventory, politics in deterministic models, storage models, dam type models, dams with discrete input and continuous output replacement theory, deterministic stochastic cases, models for unbounded horizons and uncertain case, Markovian decision models in replacement theory, reliability, rel- reliability, failure rate, system reliability of growth models, network analysis, directed network, Max Flumin cut theorem, CPM, PERT, probabilistic condition and decisional network analysis. Unit 6 Unit 6 Functional analysis, Banach spaces, definition and example, continuous linear transformation, Banach theorem, natural embedding of X in X, open mapping and closed graph theorem, properties of conjugate of an operator, Hilbert space, orthonormal basis, conjugate space H, adjoint of an operator, projection 12 as a Hilbert space, LP space, holders and Minkowski inequalities, matrices, basic operation of matrix, determinant of a matrix, determinant and spectrum of an operator, spectral theorem for operators on a finite dimensional Hilbert space, regular and singular elements in a Banach algebra, topological divisor of zero spectrum of an element in a Banach algebra, the formula for the spectral radius and semi-simplicity. Unit 7 Complex Analysis, Introduction to the concept of analytic function, limits and continuity, analytic functions, polynomial and rational functions, elementary theory of power series, Maclaurin series, uniform convergence power series, and Abel's limit theorem, analytic functions as mapping, conformality arcs, and closed curves, analytical functions in regions, conformal mapping, linear transformation, the linear group, the cross ratio, and symmetric complex integration, fundamental theorems, line integrals, rectifiable arcs,